Hey folks, welcome back for another episode of Code Club. A couple weeks ago, I was exploring the interwebs, looking for some cool data visualizations to share with you all, and to, of course, make using R, which is exactly what we're going to do in today's episode of Code Club. I came upon an article from Tom Calver, who I was not familiar with. It appears that Tom writes for the Times, and he writes an article under the heading of Go Figure. His articles have a lot of data in them and data visualizations. And so this article, we keep pumping money into the NHS. Is it a good value? This is the National Health System over in the UK. Here in the US, we don't have such a system. And so you can see that there's a variety of different plots in here showing health service satisfaction and value for money. And so this is the one that we're going to come back to that I thought was really interesting. And then further down, he talked about looking at data for room to improve in terms of life expectancy, as well as kind of hospital beds per 1,000 people, right? So basically the question was like, should we keep putting money into healthcare? And what is the return on investment for healthcare? And so this is the plot, which, you know, like everything good coming out of the UK is a great opportunity to beat up the US. And I would just point out that we happened to win a little war a couple hundred years ago. Anyway, no, it doesn't look good for the US that we spent a ton of money on healthcare, but our life expectancies don't move any. They don't improve significantly, right? That we by far spend the most money per person in the world, and our life expectancies don't match what you see from these other countries. Some countries like Italy improve life expectancy with very small increases in healthcare spending. Others like Germany, you know, it seems to kind of be going up and to the right. Canada, France, Japan. And the concern is that the UK is kind of plateauing, much like the US is. I like this figure, and what I want to do is build a static version of this plot. And so this is the version that we are going to create. Again, this is a static version. I basically did a screen capture of that page. And there's a variety of things in here that stuck out at me that I really liked. And so one of the things just right off the bat is that this is what you might call a bubble chart. It's a scatter plot where the size of this plotting symbol is connected to some variable. In this case, it's connected to time, right? So you have these little points like this one here that goes back to 2000, whereas the largest point is from 2023. There is no data in here from 2020, 2021, and 2022. I suspect that is because everybody was spending tons of money on healthcare because of the pandemic, and it probably had pretty detrimental impacts on overall life expectancy. Something else that's interesting to me is that for the US, the plotting symbols fall below the bottom axis, which is odd. The axis labels on the x-axis and the y-axis are inside the plot, and they have this dark gray color. They have kind of two fonts or two colors of font, and a font face. I believe the bottom here is a bolded gray, whereas the top line in the caption here is a kind of plain font in black. One of the other things that really caught my eye was that UK here, instead of being written in red bold text, which is what I might normally do to connect it to the UK here, instead, it's in white bold text with a red background. And so I thought that was really cool. And so there's, again, probably other things we'll discover as we go through building out this plot. But let's go ahead and head over to our studio and we'll get going building this plot today. I've already got a script, healthexpenditure.r, set up here. If you want to get a copy of what I generate over the course of today's episode, by all means, go down below to the description for this episode, and you will get a link to a blog post where you'll get the code. The other thing I'll put down there is a link to that original article from the Times. And then finally, I will also include a link that shows my 30,000 foot view of this plot and how I would kind of go through building the plot. And it's kind of written out rather than using code to build that. So I hope you explore those. And while we're having this little chat, why don't you go ahead and click that thumbs up button for me. That'll help make sure that you and others see the next video when it's released. So let's go ahead and load all this stuff. I'm loading the tidyverse, the show text. This will get us the Roboto font, which is the font I'm pretty confident that he was using. I also already have in here a ggSave statement to create a PNG that's in the same dimensions as his figure. Now, I was able to get this dataset CSV off their website, including the data. You could probably go to like the OECD and other websites to go ahead and get it. I was kind of struggling to do that, to be perfectly honest with you. And so I was grateful that I was able to find this dataset.csv at this URL. And so we can use this URL actually to read the data in. And so let's go ahead and do read_CSV on this as a string. And so this reads it in. And right off the bat, I notice a problem, and that I used CSV, which is using commas as separators. And wouldn't you know it, that it actually has tabs. So this should be TSV, but that's not what the file is called. So instead, what we could do is read_TSV, read it in, and now we get the country, the year, the amount of spending, which is on the x-axis, life expectancy, which is the y-axis, label, and size. And so I think label and size were what he was using to size the points and put those labels on there. So I'm going to go ahead and remove label and size, and I'll write out this LE to be life expectancy. So I'll do that with a select. So I'll do select, country, year, spend, and then I'll do life expectancy equals LE, and that's probably all we need, right? That gets us those 4 columns. So now we want to go ahead and pipe this to ggplot, right? So let's start by making a scatter plot. And so we'll do AES. So on the x-axis, the column we want is the spending, and the y then is going to be the life expectancy. And so then let's go ahead and do geom_point. And so that gets us our scatter plot. And so you can see here like the line for the US and all the other countries in the middle here. I think this line going up is Japan, and this over here is Italy. So let's go ahead and take the next step and color our points by the country. So to do that, in here in our AES statement, we can do color equals country. And so now we see we have all these different colors corresponding to the different countries. As predicted, this blue, or these points up here that are blue, are Japan. The UK is this purple color here. Yeah, so great, we're on our way. Now let's go ahead and change the size of our points to be associated with the year. And so in here, again, in the AES, we can do size equals year. And so now we have sized our points according to the year, right? And so we see the legend over here on the right side. We can compare it a bit to what they had here in the plot. And so we'll see that we'll probably end up wanting to change the sizes of those points. One other thing that I'm noticing in their plot is that they have a border. So the most recent year has a black border, and the previous years have a white border, right? So to do that, we need to change the plotting symbol as well as our aesthetics. We can do shape equals 21. And so now what we see, because we mapped the country to the color again is the border of plotting symbols 21 through 25. And so we want the fill to be mapped to country. So let's go ahead and do that. So we'll go ahead here and do fill. And so now what we see is that all of our circles have that fill, but they also have a black border. We only want the most recent year to have that black border. So I'm going to create a new column that says if it's the most recent year, then we want the black border. Otherwise, we want a different color. We want white, right? And so again, if I look at these two lines, that we find, well, what do we find? Well, I'm forgetting what the most recent year is, and I believe it's 2023, but let's double check. And so we can come in here and we can do arrange minus year. And so we see, sure enough, the most recent year is 2023, okay? So what are we gonna do? Well, we're gonna create a new column, and we can do that with mutate, right? And so we can do mutate, and we'll say this year, and I'll say this year equals 2023. So if it's this year, if it's 2023, it's going to be true. Otherwise, it's going to be false. I have all falses here, right? So let's go ahead and arrange by country. And so we can see Canada here, right? And it's all out of whack, the order for the year by Canada, but we can see that 2023 is true and the other years are false. Cool. So now we can take this year and we can use that as the variable that we're going to map the color aesthetic to. And I'll do color equals this year. And let's go ahead and put some of these on separate lines so we don't scroll off the right side of the screen. And so now what we see is some really garish colors, right? So if it's this year, we get this teal color. If it's not this year, we get this reddish salmon color, right? And those colors just look really hideous, don't they? So maybe the first thing we could do is the color to get the black and the white, because that won't require us to figure out what their fill colors are. It'll be a lot easier. We'll start using our scale function. So I'll do scale color manual, and our breaks are going to be false and true. And then our values are going to be the colors that we want to map to false and true, right? And so false is going to be white, and then true is going to be black. And so now we see, sure enough, we have the white border for the previous years and the black border for 2023. So let's go ahead and get our colors to match. Again, we're going to want them to match this color scheme. And so why don't we start that? I'm going to come back to my read TSV, and I'll do a select on country, and I'll do a distinct. And so this will get me my listing of countries, so I don't forget anybody. And so I'll be sure to remove this code because I would forget to remove that code. All right, so we'll come back down here, and then we'll do scale, fill, manual. And then our breaks are going to be those country names, right? And so give me 2 seconds, and I'm going to clean these up and put them into that vector, and I'll be right back. Great, so I formatted that C vector to get those country names to be the breaks. And so I want to bring back one of these parentheses here, and now I need to add the values. And so then we're going to plop in here the color values for each of those countries. So I'm using my digital color meter that comes built in with the Mac operating systems. I'm sure Windows has its own thing. There are also web apps that will do this for you as well. But I'm going to put my cursor over each of these countries, do a copy, and then we're going to paste that into the corresponding value. So now we want to do France, and now Italy, this green, and then Germany, this yellow color, and then the UK, and then the UK is this red color, and then Canada is this pink color, and then Japan is this gray color. Great. So now when we run this, we should get our fill colors to match what was on the original plot. And so now what we see is that sure enough, we have the green for Italy, the gray for Japan, the blue for France, the pink for Canada, the red for the UK, the yellow for Germany, and that blue for the United States. It's coming into form. I already see a couple problems with like the UK getting buried. We'll come back to that. Let's go ahead and see if we can't clean up the size of the plotting symbols. Their plotting symbols are really small, and then they gradually get bigger. Ours seem to have like a big jump. And so maybe we can think about modifying the size of the plotting symbol so that it looks more along the lines of what they have in their plot. So if we come back, we're going to add another scale. So we'll do scale, size, continuous. So in here we can do range equals C1 to something. Why don't we maybe do like 0.5 to, let's say, 5. And so that certainly changed the size of things. But at the same time, I'm noticing that that first year, the 2000 point, seems a lot smaller than all of the subsequent points, doesn't it? And I'm pretty sure that we have data after 2000. Let's go ahead and look at that really quick. And here we can do, I think I can do just distinct on year. Yeah, I didn't need to do the select before. And so this is out of order. So let's go ahead and order it. And we'll do arrange. So that's not ordering it. It's clearly not in the right order. So let's arrange it by year. That's better. Okay, so it does start at 2000 and goes forward. Okay, I think what we'd like though is maybe bigger contrast between the 2023 point and the 2019 point. And so I think what I'm going to do is, again, I want to have a more linear gradient between 2000 and 2019. And then I want that next point to be a lot bigger, right? And I don't know why I'm not getting that same type of scaling. Maybe it is, and I can't see it because we're really bad at seeing variation in size. What I'd like to try is to rescale these values. And so what we'll start by doing is maybe we'll look at the number of years since 2000 and kind of scale it that way, rather than using 2000, through 2020. Does that make sense? If not, hold on, we'll see it soon enough here, right? So in here, I'm gonna go ahead and do my size, and I'll do year, and then I'm gonna do the modulus operator, which is 2% signs, and I'll do 2000, right? And so what that does is that modulus operator shows you the remainder, right? So if I do 2025, which is this year, modulus 2000, we should get 25, because if you divide 2000 into 2025, you'll get 1 with the remainder of 25. I know this takes you back, perhaps back to the days of long division, 25, right? So now if we look at this, object country not found. Why? Oh, because I still have all this stuff in here. I told you I would forget to remove it. All right, so let's go ahead and try this again. And so now what we see is my size on the right, and it's a double. Okay, so let's use my size in place of the year for the size. Let's see if that changes anything. So not really, that doesn't really change anything at all. Maybe for the size, we could add value to the size of the 2023 point, right? And so we could come in here then and do my size equals, I'll do if else, year equals 2023. Then let's make it size like 40. Otherwise, let's use my size, right? So as I'm typing this, I'm realizing that for the year 2000, I'm going to get a 0. I don't know what that's going to do. So why don't we go ahead and add 1 to my size? So I think that's a bit closer. I still don't totally like this separation. I noticed that my stroke, though, seems pretty thick. And so maybe the thick stroke is hiding some of that fill, right? Why don't we go ahead and change the stroke thickness? So the stroke is the thickness of the border. So we'll do stroke equals 0.5. So I think that was the default. So let's maybe drop that to 0.25. And so that gets it to be a bit thinner and more crisp. Yeah, that last point is really tiny, I'm noticing. I don't know what to do. Why don't we adjust our scale size continuous up a little bit? Let's do 1 to say 6. I think that's pretty good. Kind of looking down here at the US, like their points are a bit closer in size to my points. And I don't really know why my last point here is so much smaller than everything else. Whatever, let's move on for now. And we can come back to that later if we get any other bright ideas. Let's go ahead now and remove the legends on the right side. I'm going to go ahead and remove all of them by doing a theme, and I'll do legend.position equals none. In the past, what I've done is gone up into the geoms and do show.legend equals false. This gets you the same thing, but it does it for all of the legends. Great, so that cleared up some space on the right side for us. And now something I'm noticing is that the order of the countries doesn't match what they have in their plot, right? So for example, for them, Italy is on top of Japan, UK is on top of France and Canada. Whereas for us, again, like Italy is behind Japan and the UK is buried inside of all the other countries, right? Something I'm wondering is the data, as we kind of looked at it for these first few lines, is in kind of a whack order, right? So we have like country and it's all out of order. The years are all out of order. And so I wonder if we reorder the country and the year, if things might behave a little bit better. So we'll come over here and let's do country. So we'll do arrange country, comma, year. And again, just to prove to ourselves that we've seen this before, that gets the country and the year in the right order. So let's go ahead and incorporate that in the pipe. Great. So now we have the UK on top of France, which was on top of Canada. That looks good. But Italy on theirs is above Japan, whereas for us, Japan is on top of Italy. And so I think what we want to do is make a factor to specify the order we want, because it's not putting things down in an alphabetical order, if that makes sense. So I'm going to grab this vector of countries, and then let's come back up to our mutate, and we'll go ahead and do country, and we'll do it as a factor on country, and we'll do levels, and we'll give it that vector, right? And again, the order that we want this is the order that we want things put down, right? For the most part, it's alphabetical, right? So we'll do Canada, France, Germany. So let me go ahead and put US at the end here, and we'll clean this up in a bit. Germany, Italy, UK. Let's go ahead and move Japan. I've got quite a mess here, don't I? All right. I've got too many commas and not the right places. All right. If I move the arrange down now, this should get us exactly what we already have, right? Yes, that's exactly what we already have. The UK is on top of France, which is on top of Canada, but Japan is on top of Italy. But what we want to flip Italy and Japan. So let's go ahead and take Japan. Let's put it before Italy, and let's clean this up a smidge. Now what we find is that Japan is behind Italy, and we get the same order of points that they have in their plot. One subtle thing that I'm noticing in theirs as being different from ours, up to 23, they were putting older points on top of newer points, right? So like if you look at like this Japan series, that this point is on top of that point, and that's on top of that, right? And so forth. But the newer point is on top of the 2019 data, right? Whereas with ours, we put the oldest point down, right? So that's the first year, right, in our data frame, going to the more recent, right? And so you'll see like Germany here, 2023 is on top of that yellow point, which of course they have here as well, but you'll kind of notice the order of the points is opposite of their points. I think our bubble plot looks pretty good. Let's now go ahead and think about styling and formatting our axes. So let's start with the axes and getting the right numbers on the axes. So let's start with the x-axis. And so we want it to go from 3,000 to 11,000, but there's a bit of an expand. I'm going to turn off the expand so that I can like really specify the right values. So again, this is another scale. We'll do scale x continuous. And I'm also going to add chord Cartesian, and we'll do expand equals false because I want that turned off for everything. Looking at that, then we see that our data goes right to the edges of the plots. Of course, we want a little bit of space, right? And so this smallest value for the UK, I'm curious what that is. That's the smallest spending level, right? And so let's go ahead and then pipe this to arrange spend. And so the smallest value here is 2,333. So why don't we go ahead and make that 2,300. I'll go ahead and before I forget, I'll remove that arrange spend. So in scale x continuous, we'll do limits equals C 2300. And then again, we want it to go out past 11,000 by, I don't know, maybe 300. So let's do 11,300. And so on the left, I think we need a little bit more room. So let's go ahead and drop that down to 2,100. That's a decent space. And again, we might fiddle with things as we go. Now let's go ahead and change our x-axis labels to go every 1,000. And so in scale x continuous, we can then do breaks equals seek. So let's do 3,000 to 11,000 by thousands. And so that'll give us those 1,000 increments on the x-axis, right? So now we see that there. Now we want to have the commas. And for the last one, we want that $sign, all right? In here, we're going to put our labels. And I'm going to give it a vector of vectors, all right? And so let's go ahead and grab this seek. And we're going to go from 11,000 to 10,000 by thousands. And I'm going to put this inside of a format. And so let's make sure I get the right parentheses here. And then we're going to want, I think it's big dot mark. I'm not in the right place. All right, let's move that over. Parentheses, big mark, is that right? Equals comma. And so if we take just this part with the first part and plop that in here, we see now that we get a comma after, or in the thousandth place, right? We've got a leading space here, and I don't know that I want that leading space. So let's go ahead and look at the help for format, and trim equals false. I think the trim is whether or not to remove that first padding, right? If false, logical, numeric, and complex values are right justified with a common width. If true, the leading blanks are suppressed. So yeah, I want to go ahead and get rid of that trim. So I'll do trim equals true. And so now let's rerun that format. And so now we get nice tight numbers. But of course, we need to get onto this, the last value, which is going to be $sign 11,000. And it's upset, unused argument, labelays. I misspelled labels. I seem to do that a lot on these episodes, don't I? Now we've got our values formatted the same way they do. Let's go ahead and change the font. And so in theme, we can do text equals element text, family equals Roboto. And so now that gets us a Roboto font that matches theirs. Theirs is black, ours is a grayish color. So let's go ahead and do axis.text. Well, X. We'll go ahead and do element text color equals black. And so now we've got our black font. I think it's right about the same size as their font. So that's great. Now let's think about the y-axis. So the y-axis, I think, goes from about 77 up to 86. So we'll come back up here and do scale y continuous. And we'll do limits equals, and I already forget what I said, 77 to 86. All right, and 86. Get a plus sign on the end here. It's warning me, removed 3 rows containing missing values. And that's because we have these 3 points for the US that fall below that line. I don't know why they made the plot this way, but hey, I'm trying to recreate their plot, and what do you know? That's what they did. What we want to do to be able to show those points, but have that Y limit, is add this to chord Cartesian. And so I'll plop that in here. And again, this is going to be ylim rather than limits. If we run this, nothing changes. We don't get that error message, but we don't see our points, right? And so to see those points, what we need to do in chord Cartesian then is do clip equals off. And now we see the 3 points that had gotten clipped for the United States. So now we've got our y-axis again. It goes every 2 years, and so that matches. Let's go ahead and make that black. And so again, in axis text, I'm going to remove the .x so that axis text then will modify both y and x. And so now we've got black font on the y-axis. Of course, we do have our Roboto font matching theirs, which is great. Let's go ahead and remove the tick marks and add the axis lines. And so we'll go ahead and do axis.ticks equals element blank, and axis.line equals element line. And so now we got rid of the tick marks and we have our black line. Our black line is quite a bit thicker than theirs. We'll do line width equals 0.25. And so I think that's about the same thickness as their line. So they have the major grid lines as being gray. So let's go ahead and change the color of our grid lines and get rid of the minor grid lines. And so we can do panel.grid.minor equals element blank. Right, so now we got rid of those minor grid lines. And now we want to do panel.grid.major equals element line. And we'll do line width equals 0.25. I noticed that ours are kind of chunky. And we'll do color equals gray. And so now we have our gray grid lines. But let's go ahead and get rid of the background. And so then we can do panel.background. And we'll do element rect. We'll do fill equals white. So that then fills out the background to be white. Let's now go ahead and get rid of our axis titles. Back up here with axis, we can do axis.title equals element blank. So let's go ahead now and add our title and subtitle and caption to the plot. This looks like it is not quite aligned with the panel, but it's certainly not aligned with the plot, right? So there's a plot title position argument that allows you to align these things with the plot. So it'd be far left side of the plot or on the axis, which is the panel. So let's do it on the plot, and then we can bump it over with a margin, right? So let's go ahead and take all this text, and I'll copy it, put that maybe after a chord Cartesian. I'll paste that in. And so we're going to do labs, and we'll do title equals this value for money. And so that needs to be in quotes, and then a comma, subtitle equals how life expectancy and all this has stalled. And so this U needs to be capitalized. All right, so then let's go ahead at the end here and close that off with a parentheses and the plus sign. All right, so it's there, good. And we need a line break, right? And so in theirs, it's after the 2000. And I'm thinking of how I want to do that. So we could do \n to get a line break, but we're gonna have to use some HTML here, either to, I think, get the background color as well as to change the font color. Let's go ahead and use library ggtext. We will go ahead and put a break in after the 2000. So we'll do BR there. And then for the plot.title, so we'll go in here and do subtitle, right? We'll do element markdown. And so that got our wrap. So before we get too far, let's go ahead and put the caption in the bottom here. We'll go ahead and copy this. We're going to kind of do the same type of thing here. And I'll paste that in. And we'll have caption equals this, right? And so that needs to be in quotes. And again, we're going to have another break here. Again, we're going to have different font colors. And so I think it'll be best to use element markdown to do that. And we'll close it with a quote here. Oh, I forgot a comma at the end here. That's why it's giving me that angry red squiggle. All right, and so then caption needs to also be in element markdown. And so I will go ahead and copy this down and we'll do plot caption. And so now I've got my caption right justified, but it's there. All right, now we're ready to start formatting this stuff, all right? So let's go ahead and make the title bolded. And I think the font needs to be a little bit smaller than it is. I don't know what size it currently is, so we'll have some work to do, okay? So we'll go ahead and do plot.title equals element text, and we'll do face equals bold, and let's do size equals 15, just a shot in the dark. All right, so it's bolded, but it's too big. So let's go ahead and maybe take that down to say 13. So now the subtitle looks about the right font, but the line height is not quite right? So let's go ahead into plot subtitle, and we'll do line height equals, let's do 1.1. Okay, so that's better. You can see it's separated a little bit. So let's up it a little bit more. Let's do 1.3. I'm noticing perhaps a little bit of space between the subtitle and the title. So let's go ahead and put a little bit of margin in at the top there. And so again, here in this plot.subtitle, I'll do margin equals margin, and then T, let's do 10. Okay, that's too far. So let's go ahead and drop that down to say 3. So that looks great. Of course, there is a bit of a margin that should be there below the subtitle and the plot. So let's go ahead and add a B, and let's make that 5. Okay, that can be some more. Maybe that should be like 11. Wonderful. All right, so our title and subtitle mostly look right, yeah? But this UK needs to be changed. So let's come back up to our subtitle, and around that UK, let's go ahead and put in some HTML. We'll do span, and we'll do style equals, and then a single quote, I'll do color, and then I'll do white. Close that brace, and then we'll close that tag, and then after the UK, we'll close the span. And then the UK disappeared, right? Maybe if I hover over it, nope, I can't see it at all. And so we need that red background, right? So ggtext doesn't have all of CSS at its disposal. And so let's see if it will use background color, which would be how we would normally change the background color of text. And so then let's go ahead and grab the red, which is this, and put that in there as the value for the background color, and see if that gets us a red background. And it doesn't. It did nothing. And when I kind of did some digging, it looked like ggtext actually doesn't have background color available at this point. So I'm going to go ahead and remove that background color, and we'll try something else here. So let's go ahead and remove that. Don't worry, I think we can still do this. That all still works. And what I'm going to do is I'm going to add an annotation. So I'll go ahead and put that after my geom point. We'll do annotate, and I'm going to do a geom equals rect for a rectangle, and that needs an xmin, an xmax, a ymin, and a ymax, okay? And we're going to plot this rectangle outside of the plotting window, right? I'm going to treat this background as a rectangle, right? So it's going to go right up. And so I'm thinking that, well, you know what? Before we do that, I'm a little bit worried about our margin and that we're going to need to move this to the left a smidge. So let's go ahead and move it to a smidge to the left, the title and the subtitle, before we worry about putting in the rectangle. Because we're going to figure out the coordinates for the rectangle and then have to move it when we move everything with that margin to the left. And so again, back in here in theme, we'll go ahead and do plot.title.position, and we'll say plot. While I'm here, I'll go ahead and do plot.caption.position as being plot. It's upset because I still have all this stuff in here for my annotate. So let's go ahead and comment that out and try again. And so now we've moved everything over. But now we want to put a left-hand margin on our title and subtitle. And so I think we already started the margin for the subtitle. So let's go ahead and start with that. So let's do L equals 10. And actually, that looks right about right. Maybe we'll move it over to, say, 8. And I will call that good. Good. Now let's put that for the title. And we'll, for the title, do margin equals margin. And we'll do L equals 8. And so that lined it up on the left, but we lost some of the margin below the label, below the title, right? And so then let's go ahead and we'll do B equals 3. So let's go ahead and up that to B equals 5. Now we're ready to put in that red rectangle. So where's that going to go? So I believe our limit on the x-axis, we had listed up here, right? And so that was at 2100. So let's go ahead and put it at like 2005 or 2050 on the x-axis. We'll go ahead and uncomment this. And so then our x-min, let's put 2050. And then that's going to come over to here, which will be about, let's say 2500. And so we'll put 2500 in there. And then our y-min, if this is 85, 86, I think this is like 86.25. Let's try that. So we'll do 86.25. And then our y-max, we'll go ahead and make 86. Let's go ahead and just make it 87. And then what we want is we want our fill to be that red color, right? And so I have that red down here. Grab that, plop it in for the fill. It's complaining that it removed one row containing missing values. And that, again, is because I have the limits for x set in scale x continuous. And so I have 2050, which is outside of that range, right? So I'm going to go ahead and remove my limit for the x-axis down to chord Cartesian, where I had it for the y limit. So we'll do xlim here. And then let's go ahead and drag this over and kind of get things cleaned up. So we've got our rectangle, right? But it needs to be bumped over. And I'm also noticing that our UK is not bolded. So before I forget about that, let's go ahead and make our UK bolded. And we can do that by putting 2 stars on either side of UK. And so now we see we've got that bolded UK, but we need to move our rectangle to the left a bit. And so this is going to take a little bit of tweaking. And so again, we want that back up here and annotate. Let's go ahead to 1900. That's good. Now we need to bring the right side over a bit. And so this is a little bit tedious. Don't you think? So let's do 2100. Oh, that's too far. Let's split the difference and do 2300. Now we need to bring the top down ever so slightly. So hopefully you're seeing what we're doing here. So let's go ahead and make this 86.75. That can go up more. Let's take that up to maybe 86.9. I think that is good. And now we want to bring the bottom up. And while I'm here, I'm going to go ahead and put up a little bit more. So we'll put 9.5. And then this needs to come up. And let's maybe make that 0.4. And maybe we can bring that down 0.05. We just want to make everything look just right. So let's worry about our caption on the bottom. Again, their caption is left justified, and it's a little bit smaller font than what we have. So let's go ahead then, and in our plot caption, so we'll do hjust equals 0 to make it left justified, and we'll do size, let's do 8. Again, I don't really know what size that is, and that's actually probably pretty close. It's probably like a 7. So let's go ahead and drop that to 7. And then while we're in here, I'm going to take this second line and I'm going to put a span around it. And I'm also going to make it bolded. All right, and then we need to close out the span. And in here, in this span, we're again going to do a style and we'll do color gray. Very good. Maybe it is an 8. I don't know. It looks like it's a in-between size. But we again need to play with the line height to separate these two lines. So let's come back to our plot caption element markdown. Again, I'll make that 8, and then we'll do line height. And let's do 1.3 again. So maybe I could go to 1.5, but we also need to bring in the margin on the left side. So I'll make this 1.5, and then we had a margin on the left of 8 for the title and subtitle. So let's go ahead and bring this up, and we'll do margin equals margin, L equals 8. Great. We need a margin on the top though, because there is a bit of space here. We'll do T equals, let's say 12. And wow, somehow I guessed that just right on. So while we're futzing with titles and whatnot, let's go ahead and put life expectancy on the y-axis and per capita spend on the x-axis. So to do this, I'm going to use an annotate. And so we had one annotate already up here for that red rectangle. So we'll do annotate geom equals text, and then we're going to give it 2 x values and then 2 y values. So let's start with the y-axis label, this life expectancy, that I believe our left limit on the y-axis, I forget these things so quickly, was 2100. So let's try like 2150. And then on the y-axis, it's right below 86, right? So let's do 85.8. And then our label will be life expectancy. Okay. So we'll go ahead and put this into a vector as well, and that needs to be quoted. And I forgot a plus sign at the end here. So now we've got life expectancy, but it's center justified. But it looks like it's in the right place vertically. So let's go ahead and make it left justified. And we can do that back up here with this annotate. And we'll do hjust equals 0. And then let's also go and do font face equals bold, and then family equals Roboto. So that's like bang on the right spot. The font is too big, and also their font is a dark gray color. So let's go ahead and see if we can make it smaller, and we'll do that up here. So we'll do size equals 8, and then color equals gray, 20, 30, I think 30 might work. Well, that's way too big, and that's because I used 8 as an aesthetic, not 8 for point size, right? So we'll do size.unit equals pt to get it to be point size. Cool. Let's make it maybe 9. So we'll make that 9, and that's probably too dark, so I can't help it. So let's go ahead and bring it down to say 50, and that looks right. So now what we want to do is do the same thing, but for our x-axis with that per capita spend. So I'll go ahead and copy that, and we will now start figuring out the values for our x-axis label. So we'll go ahead and put per capita spend in quotes, and here I will use that \n line break. And on the x-axis, we can make this actually right justified on the right limit. And the right limit is what? The right limit was 11,300. And so we'll plop that in. And then our hjusts, I'm going to go ahead and move this up because I'm going to give it a vector. So we'll do 0 and 1. So it's going to be left justified for the y-axis and right justified on the x-axis. And then our y value, I think this will be between whatever our y limit on the bottom is and 78. And what is that? Our y limit on the bottom is 77. So let's make it 77.5. Cool. Let's go ahead and reduce that line width a bit. We'll do line width, and let's do 0.9. I did line width, I meant line height. And so we'll go ahead and adjust that here. So that brought it together, and I think it looks pretty nice. And so we're looking good. Now what we need to do is go ahead and add our country labels. And so we see those labels are in a darkish gray color, probably the same color as our X and Y axis labels. So I will go ahead, and I think there's 7 of them. So I'm going to make a table of them. And so in here, we'll go ahead and do country labels, and we'll do tribble, and we'll do country. And I'm thinking about how I want to do this. And so I think what I want to do is I want to get this coordinate, right? Which is like the 2023 data. And then I want to add a nudge value for how to move things, say left or right, okay? So why don't we start by grabbing this data, and we'll do filter year equals 2023. And so this will get us all of this data. And let me plop that in here. And let me go ahead and remove that filter before I forget, because I will. And let me go ahead and clean this up, and I will be right back. So I've made this tibble, which again is the data for each of the 7 countries in the year 2023. So I guess I didn't need to show this year column, but whatever. And then we have the spend, that's the x-axis, life expectancy, the y-axis, and then the amount that we want to nudge it off of the x and y coordinates. Okay, so let's go ahead and load country labels. And it is unhappy with me because I forgot a comma at the end here. All right, now it's happy. With our geomes, I'm going to go ahead and do geom text, and I'll do data equals country labels. And our AES, we'll do label equals country, and then we'll do color equals gray 50, I believe was what we had used previously. And so it's not happy with country labels because I forgot what I called it. Oh, maybe I forgot to load it? Oh, I spelled it wrong. I called it county labels, not country labels. So that needs to be country there. And it's complaining about object mySize not found. And that means that I need to tell it to ignore the AES. And so we'll do inherit.aes equals, we need inherit AES equals false because geom text is inheriting all of these AES values and all these columns. And my country labels doesn't have a mySize, right? So that should work now. Oh, and because I told it to ignore the aesthetics, it ignored the aesthetics. It did exactly what I told it to do. And so we now need to tell it what to put on the x-axis. So that's, again, going to be spend, y, life expectancy. Great. So let's go ahead and change our font to be the Roboto font. And again, in these text elements with the geoms or the annotates, we need to define the font family separate than what we have down in the themes. And so here we can, again, do family equals Roboto. So I feel like my font is a little bit bigger than their font. And I think their font is about the same size as that y-axis label. And so that y-axis was a size of 9. So I'm going to go ahead and copy this and bring it back up here. And let's see if that works. And so yeah, I think that made the font a lot more compatible. And so now what I want to do is move Italy up. So I want to move it up perhaps half a year, so 0.5. And so then to get this y nudge, then down below in geom text, I'm going to nudge x equals, and I'll do country labels, $ x nudge, and then nudge y equals country labels $ y nudge. And there you go. Italy has been moved up. And I think that looks pretty good. Maybe it could go up, a little bit more let's try like 0.55. So let's do one more together. So Japan, we want to move to the right? And so Japan, that'll be a nudge x. So let's make it 500. And that's pretty good. Maybe it can come back, maybe a smidge. Let's go ahead and make that 300. Oh, that's too far. Okay, let's go ahead and split the difference and make it 400. So that's pretty good. So I think we've got a pretty good nudge for the x-axis for France, Canada, Germany, and the UK. So let's go ahead and use the same x nudge for those. And so Germany will move over 500. France will move over 500. Canada will move over 500. And UK will go ahead and move over 500. Canada and Germany could maybe move over a bit more. Canada maybe 50 more and Germany 100 more. So let's up that to 550. And then Germany, let's up that to 600. Wonderful. UK is too far over. So the UK, let's go ahead and drop that down to 300. All right, maybe that's too far. Let's up that to 350. That's probably going to be good. Now we need to move the US. And so let's go on US. Let's do 0.5. And maybe that's too high for the US. Maybe I could come down a little bit. I think I wanted to move Italy up a little bit because it had the grid line right there. But here I'm trying to avoid the grid line above the US. So let's go ahead and bring that down. So instead of 0.55, let's go make that 0.5. Good. I think this is looking nice. The final thing we need to do is put that 2023 and that 2020 on our plot for Germany in that yellow color. So let's come back up, and here we'll add an annotate. And again, we'll do a geom equals text, and we're going to need an X and a Y label. And as I'm doing this, I'm realizing that it's going to get 2 points, right? So we're going to give it a vector, and we're going to have a 2000 and a 2023. And then the color is going to be the color of Germany, which is this yellowish color, right? And we'll plop that in. And we'll also want to do family equals Roboto and get a plus at the end there. And the font looks about the same size as the country, maybe a point smaller. So let's go ahead and make that 8. So I'll go ahead and grab this stuff that we used up above to make the Y and X axes. And we'll make that 8, add a space here, remove this final comma and space there. And I forgot to put in the X and Y. I think I'm getting tired. All right, so what is the X going to be? So this is 6,000, 7,000. It's going to be centered. And so I think it's going to be like 6,400. So we'll do 6,400. That's actually for the 2023 one, right? And so here, I think it's going to be about 4,200 for the first value. Again, we'll have to adjust most likely. And so then here, it's right at about 78. Let's make it maybe like 77.9. And then what for Germany? So Germany is like right in the middle. Let's put that at 81. So we said 81. The 2023 looks good. It could be bolded, I think. Our 2000 needs to come over to the right a little bit. So let's go ahead and do that here. And we'll do font face equals bold. And I said the X needs to come over. So let's maybe make that 4,300. And so that's over well, but I feel like the top is getting clipped a little bit by that grid line. Let's go ahead and maybe bring it down below the grid line. And so we can do that again here. Let's make it like 0.85. So I think that looks pretty good. I don't know that they used bold. I think maybe their font was a little bit bigger. Let's go ahead and just change that real quick. I'll go ahead and comment out this font face bold, and let's make the size 9. Yeah, I feel like their fonts are a little bit more substantial than our fonts, right? And I don't know what the difference is. I have a hard time sometimes matching the Google fonts, but I think we've done it, right? I'm pretty happy with our ability to recreate the original figure here. We had a number of pretty cool things that we did, like this red rectangle behind the UK. I might clean this up a little bit. It looks like there's a little bit too much padding on the bottom, but I'll save that for later. And kind of, again, from everything from like styling the axes to letting the points flow down below the line. So if I had to say like something that kind of nags at me that I didn't get quite right is the size of the plotting symbol. Ours seems to kind of go up in size a lot more rapidly than theirs, but you play with it and let me know if you figure out how to get those plotting symbols to match theirs a little bit better. Also, if you know what I'm doing wrong with my Google fonts, please let me know. I'd love to know because I can't seem to kind of really capture the density of their font. I don't know if that makes sense. Anyway, again, I think this is a pretty cool plot. So if I had to critique this, it would actually be something I like about this, right? So the critique would be, so the thing I like about this is that it's using all these points to show the flow of time, right? I think that's really cool for a static plot, right? But seeing as that this is put up on a website, I wonder what it would look like as a GIF, right? Whereas instead of showing each of these individual points, we did it as an animation. And so my concern is kind of like what we see over here with Italy, that I lose the track of time here, right? Like I don't really know what's going on with Italy. Did they lose life expectancy? And how do these points relate to all the other points, right? So I feel like this point might be bigger than this point, but I don't know, right? And so that's something where perception gets a bit lost, right? And so I think if we made this into a GIF or did it as an animation, then it might be easier to see the flow of time. Obviously, it would be easy to show the flow of time if you made it an animated thing because that would be using time. Again, I hope you've enjoyed working on this plot with me today. Really encourage you to go back and work on it on your own. Try some different experiments along the way and see if you can't get it to maybe have your own little flair to it and see if you can't get those plotting symbols to look a little bit better match than I was able to achieve. All right, that's enough. Please tell your friends about what we're doing here, and I'll see you next time for another episode of Code Club.